Okay, good morning, everyone. My name is Anna Slavec. I'm a consulting statistician at the InnoRenew Center of Excellence, and I'm the Research Data Alliance Europe Ambassador for Engineering Renewable Materials. This is a webinar on research data management for renewable materials and products. But the content of the webinar, I think it's quite general. So even if you're not from this specific field, the content might be relevant for you. Actually, when I introduce myself as the ambassador for engineering renewable materials, I usually apologize to people who are present who are engineers, because I'm not an engineer. My background is, I'm a statistician, and my background is in social science statistics. And my specialty here is data management. And but the institute where I work, there are a lot of engineers, and I'm helping them with their statistical and data issues. And so I got this grant from Research Data Alliance Europe that allows me to promote good data sharing practices in this field, and to promote the Organizational Research Data Alliance. Okay, I see there are quite a lot of participants already, so I will start with the presentation so that there will be also enough time for questions at the end. If you want to ask questions, it's possible. In Zoom, there is this Q&A section where you can ask questions, and I will read them and reply to them at the end. Also, let me know if there are some issues with sound. If you have some trouble hearing, you can also use the Q&A for that. Okay. Okay, first an outline what this presentation will be about. So as I said in the description, I will start with an introduction, what research data management is, and why should this topic be interesting for researchers, specifically for researchers in the engineering field. And I will outline what are the challenges that I found that are specific for this field. Then I decided to dedicate a part of this webinar to the topic of data management plans. This is a question that often appears, that I often get from researchers, so how to prepare a data management plan. And it's like a topic that in which I can cover a lot of the issues. So it's like an overview of all the different things, and it's something that happens at the very beginning of the data management circle. So I will talk about data management plans, what are the recommended file formats, what are FAIR principles, and how to select the most appropriate repository. And in the last part of the presentation, I will talk about Research Data Alliance, and how you can get involved with this association. So research data management describes the organization, storage, preservation, and sharing of data collected and used in a research project. It involves the decision about how data will be preserved and shared after the project is completed. And it usually, as I mentioned, it usually starts with a plan. So at the beginning of the project, we prepare a plan that deals with all of these stages. So why is this topic even important? The most important reason, I think, is ethics and integrity. Research data management is part of being a responsible researcher. Is part of the responsible conduct of research. So if we want to conduct our scientific research with integrity, it's important that we manage, that we pay attention to how we manage our research data and how we share it. You probably heard in science news that there is this reproducibility crisis in science. A lot of research that is published, it's not possible to reproduce it because the only research output that is shared is the publication. But before the publication, there are other research outputs that can be shared. And if we have well-managed and accessible data, that allows other researchers to validate and replicate our findings. There are also more pragmatic reasons. So sharing data is becoming a requirement imposed by funders and publishers. Already in Horizon project, researchers are required to publish their publication in open access, and I think it's only a matter of time that will be the case for also for data and other research outputs. Of course, there are some specifics. There will always be some exception, and I will also talk about that later. And another important reason is also that sharing, so managing data in a responsible way, it's also beneficial for us. It saves us time and resources. At the beginning, it might be an investment of time and resources because it requires, for some researchers, a big change in how they do their research. But in the long run, this is something that is beneficial. And we have to keep in mind that the main reuser of our own data is our future self. So our future self will be thankful to us that we invested in good data management practices, because it will be also easier for us to look at our own data and reuse it, because after we collect the data, with time we forget some details, and it will be also easy for us if this data is managed well, so that we will know exactly what the data is about. Okay, so as I mentioned, here are the key data challenges in engineering that I identified when talking and helping researchers in this field. Something that I noticed is that a lot of research is done in collaboration with industry, and industrial partners are often reluctant to share data. So this is some social barrier that needs to be addressed. So how to make industry more willing to share the data, or sometimes if data cannot be shared, there is this solution that at least metadata can be shared, so that other researchers know what kind of research was happening. It's also very common for researchers to fear losing competitive advantage. They fear that if they will publish their data, other researchers will use it and publish a publication for them. I noticed that this varies from field to field. In some fields, researchers are more fearful. In some fields, they're less fearful. It really depends on the field. But from my experience, usually that's not a problem, because you're the person who knows the data. You're the person who really knows the data, and you have this advantage. So even if you share the data before the publication, you have this advantage that you can do the publication first, because you're the one who really knows best. So you have some advantage. But there is also this fear of data being misused and misinterpreted. The problem is that this misuse and misinterpretation are more likely if you keep the data closed. So sharing data actually helps. So because it allows more researchers to check the data and the methodology, and so there is actually it's less likely the data will be misused and misinterpreted. And then there are two technical challenges, at least for some of the engineering fields. I noticed there is a lack of metadata standards and ontologies. Before working with researchers in this field, I worked with social science researchers, where they have specifically, especially with researchers doing survey research, which is very structured, and their data management, they have an established DDI standard, and I haven't found a similar standard for metadata for engineering fields. So every engineering field has their own standards, of course, but there is a lack of these common standards that will help with data sharing, especially in interdisciplinary research. And I noticed also a lack of domain-specific repositories. For example, at my institute, we were looking for a repository for the kind of data we are collecting, which is mostly wood samples, and we were not able to find a good solution, so we decided to use a general purpose repository, which is Zenodo. Which is a simple solution because Zenodo is very easy to use, but it lacks rich metadata. I will speak more about this issue later, about metadata and richness of metadata, when I will talk about FAIR principles. Okay, now next section, how to prepare a data management plan. So first, what is a data management plan? It's a document that outlines how data are to be handled during and after the research project. A data management plan should include a description of data to be collected, created, standards and methodologies that were used for data collection and management. It should include an ethics and intellectual property rights section, plans for data sharing and access, and a strategy for long-term preservation. To prepare this section of the webinar, I used the resources from the Digital Curation Center in the UK. They have a lot of examples of data management plans, and in particular, I used their checklist for a data management plan, which you can find here. There is a link to this resource, and there are like these 7 steps, these 7 questions to respond when we are preparing a data management plan. So what data is going to be collected or created, how, what documentation and metadata will come with the data, how will you manage any ethical and legal issues, how will the data be stored and backed up during research, how you will manage access and security, how will you share the data, are there any restrictions required, and who will be responsible for data management? What resources will you require to deliver your plan? At this point, I know that this is like not the only right solution, so it sometimes your funder has a template and some requirements what they expect you to include in a data management plan. But if you are doing data management plan and you don't have any guidelines, these are guidelines that I recommend, so following these questions, but you can always do it differently. There are really no strict rules. It's also important to know that the data management plan, even if it seems like, oh, this is a requirement, this is something I'm doing to for the funder, actually the data management plan, you're not doing it, you're mainly doing it for yourself, because it will help you in the project so that you can know in advance what are the issues you need to pay attention to, and how many resources you will need to manage the data. so it makes the project management easier for you. So when you're doing a data management plan, you have to think that the main purpose to do it is to help yourself, to make the work for yourself easier in the next steps of the project. And also, I find that some researchers are intimidated when they hear, oh, I need to do a data management plan, but a data management plan doesn't need to be very complex. In some cases, it's like a very simple document. In a lot of cases, it's just 2 or 3 pages. So it really depends on what kind of research you're doing, what kind of data you're collecting. In some cases, it's more complex. In some cases, there are more issues. So it depends on the situation. Okay, now I will go through these 7 points and talk about each of the 7. So the first thing in a data management plan is to summarize what the project is about, especially what kind of data are you going to collect. Is this some, will this be some textual data, numerical data, tables, even photos, videos? So in the engineering field, there is a lot of, for example, spectrometry, images. So also images are data. So in this part of the data management plan, you list all these types and formats of data. And if you know, you can also say what the expected volume of data is. In many cases, in a lot of research, the volume of data is not very big, but in some cases, there might be a lot of data, a lot of space, and that's an issue also for resources. So it's good to know this in advance. If you have trouble estimating the volume of data, it might help that you look at your previous project and you can see how much data you created in your previous project, and based on that you can estimate. Here you also list the software you will be using to manage and analyze the data. An important thing to know is that even if you're not collecting primary data in your project, you might be reusing existing data, so secondary data. And also in this case, it makes sense to prepare a data management plan of secondary data. So you mention what are the data sets the secondary data sets that you will be using, because that's important, because there might be some legal limitations on how to use them, accessibility issues on how to use them, and so on. In this section of the data management plan, you also mentioned the standards and methodologies that you will be using, and it's also a good idea to, especially larger projects where you have collaborators, to decide on the structure and the naming of files, so that you have some common standard how you will name the files in the project and how you will version them, so that with your project partners you can agree on the naming of the files. That makes later in the project, when you will have the final outputs, it will make everything much easier if you have this consistent structure and naming and versioning of files. And this is also a section where you mention what are the quality assurance processes regarding data that you will be using. Okay, next. Okay, at this point, I would like to mention, so when I look at data sets shared by researchers in this field, I notice that a lot of times it happens that data are shared as an Excel file in the XLS format, which is acceptable. It's better than sharing nothing, but it is better to use non-proprietary formats that are recommended. For example, if you're having an Excel file, it's better than Excel. It's better to use a comma-separated value file or a tab file. Also, Here it's important to know how to organize the data in your Excel file. Often researchers, when they collect some data, they have it in an Excel sheet all over different tables. Here, if you have several tables, you should put every table on a separate sheet, and every separate sheet should be saved as a separate file. So, so at the end, the result that you're sharing should be something that can be opened not only in Excel, but also in other formats. So here it's a good idea to use the comma-separated values. And for other kinds of data, there also, this table gives you the list of what are the recommended formats. In previous presentations, some researchers noted that these are, of course, not all the recommended file formats. This is a table that I cite from the UK Data Service. There are also some formats that I would recommend, but are not included in this table. So especially if you're using R, for example, R Markdown files and so on. So these are also all kind of acceptable formats. You can read more about this topic in the on the link that you find at the bottom of the slide. Okay, next section in the data management plan is the documentation on metadata. This is important because this documentation helps secondary users to understand your data, and only if they are able to understand it, they can reuse it. What is metadata? Metadata, the most simple definition is that this is data about data. So an example of metadata is the persistent identifier that comes with your data. For example, if you publish your data set on Zenodo, you get this DOI. Data about data is also the publication date, title, author, description, keywords, licenses, funding, related identifiers. Here I'm listing just very simple, basic metadata. These are the metadata entries that you will see if you use a repository, a general repository like Zenodo, that's using this Dublin Core metadata standard. But for more, you have also more richer metadata standards that include much more than this. So this metadata might include also details on the methodology that was used, analytical and procedural information, definition of variables, vocabularies, units of measurement, assumptions made, the format and file type of data. So metadata can be very rich. For example, the DDI standard used in social sciences, for example, for a survey questionnaire, for each question. So they have, part of the metadata is also all the variables or the questions were asked, so that metadata is very rich. So when you're looking to find the metadata scheme for the kind of data you're using, there is a resource by Research Data Alliance that might be helpful. You can find it on this GitHub link, the RDA metadata directory, so you can find here for the kind of data that you're collecting, what would be the most appropriate metadata. Okay, when talking about metadata, why is metadata important? I come here to the topic of fair data principles. Fair data is a quite recent concept in research data management, but it's a very catchy name because the acronym has this connotation of fairness. So it's a term that we use a lot, but it's not just a buzzword, it also has a meaning. So let's explain what fair means. The F stands for findable. So other researchers are able to find your data. So just storing your data, uploading them somewhere online not make them findable. If another researcher who is looking for the kind of data you collected wants to find them, you need to equip your data with rich metadata, that will make the data findable. So if somebody is looking for data on a specific topic, it's important that you list all the relevant keywords based on which another user will be able to find. Also, metadata like the date of the time of data collection, because maybe another researcher is interested in data that was collected in a specific time period, and his search will be based on this metadata. So the richer the metadata, the more easy it is for other users to find your data. A stands for accessibility. So it's not enough that the data is findable. There is also the issue of accessibility. So once the other researcher finds your data, they need how the data can be accessed, possibly including some authentication and authorization. So accessibility does not mean automatically that data can be just automatically downloaded. It might come that the user needs to be registered. For example, some of my colleagues are using data from Eurostat, and usually to get access to that kind of data, so all the metadata are available on the portal, but if you want to access raw data, if you want to work on this more on that kind of data, you need to make a proposal. So does it mean that this data is not accessible? No, this data is accessible, but there is this protocol that you have to follow by preparing a proposal. But this is something that's outlined on the website. So so we can say the data is accessible. So a researcher who wants to use the data has the possibility, and it's clear from the information on the website what the researcher needs to do to get access to data. Okay, the I stands for interoperability. Data usually needs to be integrated with other data to be interoperable with application or workflows for analysis, storage, and processing. Here, I think it's important to remember that table from the UK data service that I showed on my previous slides. So here it's important that you use non-proprietary formats so that your data can be open also in other programs, not only in the program you are using for data analysis. But interoperability is not just that. Interoperability is much more. There are discussions within the field of research data management about human interoperability, computer interoperability. There are different levels of how interoperable data is. It also depends from field to field what level of interoperability you can access. But at the beginning, as a beginner, is just one step is just to at least try to use non-proprietary formats. That's just one step towards interoperability. And the R is for usability. This is again related to metadata. The metadata and data should be well described so that they can be used in different settings. Especially this is important for interdisciplinary research, so that even researchers from other fields are able to understand what your data is about, and also for researchers in your field, and as I mentioned in the beginning, for your future self, because at some point you may be reusing your own data, so it's important that it has all the necessary metadata that tells you what this data is about. Regarding fairness, I would like to stress that this is not binary. You cannot say this data is fair or not fair. It's like a continuum. And we are striving to make our data as fair as possible, but in some cases, in some cases it's possible to only reach like a certain extent. But this is like an ideal that we are striving to get. So the more data is fair, the better, usually. An important thing to note regarding fair data is that fair data is not the same as open data. And both open and fair data is not the same as managed data. So we have data that is open and it's not managed. We have data that's open and managed, and data that can be open, managed, and fair. So of course the ideal is that data is both open and fair, but sometimes there are some reasons for data not to be open, but data is still fair. So even if data is not completely open to everyone, it is in line with FAIR principle. So when I'm talking about open science, it doesn't mean everything needs to be open for everyone. There are sometimes legitimate reasons for data not to be completely open, but all data that is fair, it's managed data. So if data is not managed, then it cannot be fair, because what makes the data fair is in a great part this richness of metadata. And by equipping data with metadata, that's managing data. So fair data is always managed data. When deciding what is more important, open or fair, I think having fair data is more important than having open data, especially if that open data is not managed well. Okay, next topic, ethics and legal compliance. The researchers I work with, although they're engineers, it often happens that they do some interdisciplinary research with social scientists. So they are testing some material properties on humans. In that case, it's also important to be aware of issues related to research on human subjects, especially if it involves like some sensitive or health issues. In that cases, the research plan also needs to be submitted to the ethical committee in charge of the corresponding research area. This is usually if it's about health. But in most of the social sciences, in my experience, there is no, if it's not a very sensitive issue, there is usually no need to submit it to the ethical committee. But still, it's very important to assess the risk of disclosure and to assess this risk before, during, and after data collection. If we are doing research on human subjects, it's important to seek informed consent, but not only for data collection, also for data processing and long-term preservation. A mistake often made by researchers is that they ask for consent just for data collection and reuse for that project, but they don't ask the participants for consent for data to be reused for secondary use. So in that case, it might happen that the repository, if you're depositing your data in a repository that has some quality control, it might not be possible to make your data open in that case. When you collect data on humans, it's also important to search for direct and indirect identifiers and to remove them or aggregate them. So some anonymization of variables is needed. And when that's not possible, the solution is restriction of access. When anonymization would hinder the usability of data, you can share the data in this repository or archive, but the data is accessible only on strict conditions. Usually, as the example I mentioned before, the data by the European Statistical Office, usually there is this restriction of access that you have to prepare a proposal if you want to access their data. When you're doing research with a human subject, it's also important to comply with the General Data Protection Regulation. But even if you're an engineer and you're not doing any research involving human subjects, the ethics and legal compliance section is important because there might be some confidential information and trade secrets in data involved. Okay. Next section, it's about storage and backup, copyright and intellectual property rights, consortium agreements. So in this section of the data management plan, we'll mention issues related to that. Here I provided the link to the Creative Commons licenses, which are the most common licenses used. In this section, you also outline if there are some restrictions or use of third-party data. You can also set some embargo periods for data sharing. And in this section, you mentioned the security measures and standards for confidential data. Okay, and selection and preservation of data. Here you make a selection of what data will be retained and what data will be destroyed because of contractual, legal, or other purposes. Here you also outline foreseeable research uses of the data. So what uses of your data you are expecting. The data will be used to validate your findings, to conduct new studies, teaching. Sometimes it's difficult to know. The research is becoming more and more interdisciplinary, so it's not easy to know all the possible uses of your data. So there might be some uses that you cannot foresee. In this section, you also outline what will be the length for the retention and preservation of data, what are the repository or archive you selected for the data, and here you also mention if there are some costs. Some repositories charge, and also you have to take into account the time and effort that will be used to prepare data for sharing and preservation. So also when you're in the stage that you are applying for a research project, it's good that you include the work hours for data preparation and sharing in the proposal, so that this is something that's part of the project and not something that you do after the project but within the project. So it's good to plan in advance already in the phase of asking for applying for the project. Regarding repositories, as I mentioned, we have different kinds of repositories. And we have this distinction between general purpose repositories, like the Zenodo repository that I mentioned. Then we have institutional repositories. A lot of universities have their own repository, and then the domain-specific repository. So usually, experts in research data management, what they recommend is always to use the domain-specific repository because it's specific for your domain and it has the metadata scheme that's most appropriate for your data. So it's better to use the domain-specific repository than the institutional one or the general one, because the institutional one and general purpose ones are usually, they have less rich metadata. So if there is a domain-specific repository for your field, you use that one. And here is a useful resource, a link to the registry of research data repositories where you can search for the most appropriate repository for the kind of data you collect. But as I mentioned, for many domains, there are no domain-specific repository. So in that case, you select between the institutional or general one, which has less rich metadata. And to improve reusability, what I usually recommend to researchers who are using Zenodo is to prepare also a README file that can be uploaded with the data, and so that the reuser can read about the description. It's not an ideal solution, but better than nothing. And at this point, maybe also a note that if you have an institution that requires you to use their institutional data repository, but you would prefer to use a domain-specific repository, the solution is to use both. So you upload the rich metadata to your domain-specific repository, and then you connect it to your institutional data repository, where you have just the simple metadata. So the data set can be, so the metadata is on both repositories, but the primary one should be the domain-specific one. Okay, sixth topic within data management plans, data sharing. So in this section of the data management plan, you say where, how, and to whom you're sharing data. Sorry. So what are the conditions for data sharing, and when you will make the data available? What are the persistent identifiers that you're using? And here you also outline expected restrictions due to confidentiality, lack of consent agreements or intellectual property rights. And in this section, you also mention non-disclosure agreements for protection of confidential data. Okay, and last one, responsibility and resources. Here you outline the roles and responsibilities for data capture, for metadata production, quality, storage and backup, data archiving, and data sharing. So some of the things, so it really depends from project to project. In many cases, the project leader is doing some of the things, but if it's a bigger project, bigger team, this is split among different people. And here it's beneficial if an institution has a data steward. The data steward can be involved in the project and help with many of these responsibilities. If the project is very complex from this perspective, it might be a good idea to have a data steward. And in this section, you also determine if additional hardware or software is needed for the project. Okay, here at the end, I include some examples of data management plans. So for engineering and material science, so here the first one, it's a data management plan for a Marie Curie project by Sebastian Dechel, who is a Marie Curie fellow at the University of Ljubljana. And he was also following this Digital Curation Center guidelines. And I'm providing the link to his data management plan. He's doing coatings, plasma coatings. And so this is a good data management plan to follow. On the DMP tool website by the Digital Curation Center, I found 2 examples of data management plans, but they are very short and simple, just 2 pages and very to the point, but it might be useful. So these are 2 examples that I found. And I'm giving here the link also to a data management plan that I'm doing. It's in social sciences, but it might be also useful for you if you will be doing any research that is involving data collection on human subjects. Okay, now the last part of my presentation is about Research Data Alliance, which is an international organization that has now more than 9,000 members globally from 137 countries. What is the purpose of Research Data Alliance? Research Data Alliance is an association that is building the social and technical bridges that enable open sharing of data and to achieve its vision of researchers and innovators openly sharing data across technologies, disciplines, and countries to address the grand challenges of society. Research Data Alliance members work together through these self-formed volunteer groups, and they work on issues like reproducibility, data preservation, best practices for domain repositories, interoperability, data citation, data type registries, metadata, and many more. If you want to become an individual member, individual membership is for free. Here I provide a link that you can use to register to become a member. There is also institutional membership, which offers then additional advantages but comes with a charge. So why should you join Research Data Alliance as an individual member? What are the benefits? As a member, you contribute to the acceleration of data infrastructure development. You can work and share experiences with collaborators throughout the world. You can access this network of colleagues with various levels of experience, perspective, and practices. You can gain greater expertise in data science, regardless of whether you are a student, early career researcher, or seasoned professional. You can enhance the quality and effectiveness of personal work and activities, and you can improve your competitive advantage professionally. And you can position yourself for leadership within the broader research community. Research Data Alliance has interest groups and working groups. Here I give a few examples of interest groups that are relevant for engineers and working groups relevant for engineers. The difference between interest and working groups is that interest groups are active over longer periods, while working groups are active for a fixed period from 1 year to 1.5 years. And in that period, they need to come up with some output. Here are the links, so you can check these interest and working groups if some of them might be relevant for the kind of work you're doing. Research Data Alliance in Europe has also national nodes. And so for your country, you can, so on this map, you can see the countries that are colored, they have their national node, and you can interact with your national node, and the nodes are also organized as groups. So when you become a Research Data Alliance member, you can also join your national node, and you can follow the news, what's happening in your country. They are organizing events and other activities. So if you join your national node, you will be informed about their activities. Research Data Alliance is not only Europe, it's an international organization. And how do these people who work together in interest and working groups, how do they work together? When they come together? There are plenaries organized 2 times per year. The next one will be in March in Australia. And if you're interested to attend it, if you're an early career researcher, there is an open call for early career and expert travel grants. So not only for early careers, also for experts, there are grants open. If you click the title of the slides, you get there. The deadline is 3rd of February, so only a few days left, but it's a short proposal. And in 2018, I won this grant to attend the 12th Research Data Alliance plenary as an early career researcher, and here you can read about my experience attending the plenary. after the plenary in Melbourne, there are 2 other plenaries planned. In November, there will be one in Costa Rica, and in next year, there will be a plenary in Scotland. Okay, here are acknowledgement of resources that I used to prepare this last part of the presentation about Research Data Alliance. And here is my contact information. I'm also providing a link to the Research Data Alliance website, where you can find a list of other Research Data Alliance ambassadors. We are a group of 14 ambassadors for different fields. So on the Research Data Alliance website, you can find information about other ambassadors. If your field is not engineering renewable materials, but another field, you can find who is the ambassador for that other field there. I would really appreciate if you give some feedback to this webinar. Here I provide the link to a survey where you can evaluate this event and leave feedback. I will also, this link will be also sent to you by email. And now we have like 7 minutes left for questions, so I will check if I received.
Yes, everybody, we have received some questions, one through the question and answer box, and a few more through the chat. Now, we will start from the one in the question and answer box. Afterwards, we will address those in the chat, but we suggest to use the question and answer box so we make sure that we don't miss any question. Okay, so I will leave the word to you again, Anna, so you can answer the question and answer box question from David. Yes.
So David Satter is asking, so he's from a company called Material Zone, which develops a platform for data management. And he's wondering when it will be compulsory to add data. So as I understand, the question is when the funders will start requiring that it's compulsory to share just not the publications but data. I don't have a response to that. I don't know. So whatever I will respond, it will be just a speculation. But as far as I know, it is a plan that it will be added at some point, but it will be a slow process because even for publications, even if it's required, it's something that is happening very slowly. So it's not something that will happen through the night from today to tomorrow. So there will be, I think, enough time to prepare, but better to start preparing sooner than later because it's something that it's going to happen. So I hope I got the question, the purpose of the question correctly. If not, David, please correct me. And now I will check the chat. So.
Okay, the chat, we can start from the question from, let's see if I pronounce it correct. I'm sorry if I make a mistake. Amparo Roca de Togores, I'm sorry if I pronounced that wrongly. It's the question that was made at 11:37, yes. Is this risk of disclosure? I will leave the word to you again, Anna, for the answer.
So is the risk of disclosure only applicable in case of research on humans or also in case of recruiting personnel to collaborate in a project as external contributors? So when doing a panel of experts? So yes, I would say so. So if this is a panel of experts, if I understand this situation correctly, in a project you have some experts who are contributing. So if we are looking at research ethics, if this is not used for research purposes, then it doesn't fall under research ethics, but it falls under the GDPR. So it really depends what is the nature of this information, if it's something sensitive or not. But I imagine it's not, if it's not something sensitive, and there is some contract between you and these experts, already the contract includes that this data will be shared in some way. But just to be sure, it's good that people are informed how you will use them. So risk of disclosure. So I see that I got from Amparo another comment. So if we intend to have some citizens and experts collaborating and we will need some data, there will be personal data such as name, phone, skills, education, mail. Yes, so this is personal data. You have names, phones, education, mail. So under the GDPR, this is personal data. So you need to have, how is it called? Some legal ground to be able to use the data. But it's not necessary consent. So one ground is consent, but if you read the GDPR, there are also other legal bases for analyzing the data. So it also depends on what kind of institution you are. If you are a public institution, it's stricter. If you're not a public institution, it's less stricter. If you're a small institution, it's even less stricter. It's even less strict. So it depends on many factors. But in any case, I think there is a solution. There is a solution for the issue you're having. So these people will provide some data. I don't know what this data will be, probably some opinions. So a safe way to go here is just to inform them how their opinions will be used, where they will be shared, and just to carefully deal with their personal information and contact information. And at the end of so that you limit the staff at your organization that will have access to their data, and that this data will be destroyed at the end of the project. So just carefully handling that data. But I would need to know more about this project to give a more detailed response. But in general, I think it's not a big issue, because this kind of data is collected very often, all of the time. So just some moderate level of awareness of this. Yes, you're welcome. So Amparo is asking if he can send me the details by email. Yes, you're welcome. You can send me the question and I will try to respond better. So then I see a question from Nina Schkerk: how to get the DOI for the data? So it depends on what kind of repository you are using. If you're using Zenodo, you get the DOI for free. But for other repositories, it might be different. Okay, then there is another attendee who is asking for a copy of the slides. Yes, I think we will definitely share the slides. I plan to upload them to Zenodo, so you will have access to the slides.
Yes, sorry to interrupt. The slide will also be available on the RDA website, and we will also send you an email with the details to access the slides.
And also the recording will be available, right?
Exactly, yes.
Okay, any other questions? Okay, so if at this point there are no other questions, but you feel free to send me an email, but know that you will receive an out of office notice because I'm on maternity leave. But when I have time, when I will have time, I will, and if it's an important question, I will try to find some time to respond. So feel free to send me any questions you have.